Okay, so hello everyone. In this video we are going to talk about the concept of internal rate of return. This concept is going to assume knowledge about net present value, so if you don't know very well what net present value is, I recommend that you go back to the net present value video. Okay, so net present value is a number that tries to mimic what we understand by what would be the average return of the project. So it's not trivial to calculate what the return on a project is, because a given project might require several phases of investment. Okay. So it's very simple to calculate return when you put money a single time, but when you put money in several steps, you might want to have a measure of your average return. Okay, and the definition of the internal rate of return is not very complicated. You might have a little bit of trouble, but it's not that complicated. It is basically defined as the discount rate, the hypothetical discount rate that makes the net present value of the project zero. Okay, so it's not the real discount rate. The market is going to define what's the real discount rate. It's an hypothetical discount rate that, if that was the true discount rate, if you use that number for NPV calculation, you would get an NPV of zero. Okay? So, in a sense, the internal rate of return is an opposite calculation of the NPV. Because on the NPV, you enter the discount rate to calculate the NPV. And for the internal rate of return, you enter the NPV of zero, and then you solve for what would be this hypothetical discount rate that makes the NPV zero. So in order to make things clear, let's go to an example. So before the example, I forgot to mention, but what's the idea of the internal rate of return? When investing in a project makes sense, given a certain level of internal rate of return. So the idea is that every time your internal rate of return is larger than the cost of capital, it makes sense to invest. Okay, because this is going to imply that your NPV is positive. The return of your project is larger than the cost of capturing funds in the industry. However, if the internal rate of return is smaller than the cost of capital, then investing in a project does not make sense, because the internal rate of return, or the return of your project, is smaller than the return of similar projects with similar risks in the market. Okay, so how can we calculate the internal rate of return, which is really the question that you are mostly interested in? It's very simple. Let's say that we have a project that pays $1.1 million in 1 year, and this is going to require an investment of $1 million. Notice that here the discount rate is not given, and this is intentional. You don't need the discount rate in order to calculate the internal rate of return. Okay? So the internal rate of return, by definition, is the hypothetical discount rate that makes the NPV zero. Okay? So let's say that this hypothetical discount rate, R, is the internal rate of return. So this is going to imply that the NPV of this project is zero. So the NPV of this project is going to be minus 1 million, which is your initial investment, plus $1.1 million in 1 year, divided by R, and this should be equal to zero. Okay, so this is going to imply that 1.1 million is equal to R times 1 million. So this implies that R is equal to 1. I'm sorry, this should be 1 plus R. So here I should have 1 plus R instead of R. Yeah, so 1 plus R here, and 1, let me erase this, and 1 plus R here. Okay, so this is going to imply that 1 plus R is equal to 1.1 million divided by 1 million, which is equal to 1.1. And this implies that R is equal to 1.1 minus 1, which implies that R is equal to 10%. Okay? Another example, a little bit more realistic. So let's say that you have a project that is going to pay $600,000 in 1 year and additional $600,000 in 2 years. And this project requires an initial funding of $1 million. What would be the internal rate of return of this project? So, again, if R, an hypothetical R, is equal to the internal rate of return, this is going to imply that the NPV of the project is 0. And the NPV of the project is minus 1 million plus 600K. Actually, instead of 600K, I'm just going to write 0.6 million. So 0.6 million over 1 plus R plus 0.6 million over 1 plus R square, and this should be 0. Okay, so this implies that minus 1 plus 0.6 over 1 plus R plus 0.6 over 1 plus R square is equal to 0. So in this type of situation, the best thing to do is really trying to solve this equation numerically instead of trying to solve by hand. It is possible to solve by hand, but the solution will be quite complicated and the calculation will be quite time consuming. So there are two ways to do this calculation numerically. You could use a calculator or Excel. So I'm going to show you how to do that on Excel. So let me just remove the table here. Now, how can we do this calculation on Excel? It's quite simple. So the first thing that we have to do is to write this formula for a generic value of R. So let's say that R is equal to 5%, and I'm going to write the NPV as a function of this R. So the NPV is going to be minus 1 million, so minus 1. I'm not going to put the millions, they are not important. Plus 0.6 divided by 1 plus R plus again 0.6, but now divided by 1 plus R squared. Okay, so this is going to be the formula that we need, and I just enter. So now we need to play around with the values of R in order to make the NPV go to 0. And Excel has a tool for that. So we can go to data, what if analysis, go seek. So go seek is a tool in Excel that sets the value of a given cell to a given number by shifting another cell. So we want to set the cell NPV to the value of 0 by changing the cell R, which is the hypothetical discount rate. Now we click OK. And as you can see, just going to give you another. That's kind of strange. So set cell NPV to the value of 0 by changing the cell R. Okay. So GoSeek gave me an answer of around 13%. Okay. And we can illustrate this number in a graph. I think that trying to understand internal rate of return visually is useful. Okay, so here we have this figure that represents the NPV as a function of R. Okay. So the NPV gets big when R is small, and this is very intuitive. Basically, we are saying that we are using very small discounts, and when you discount by small numbers, you get large numbers. So the NPV is large when R is small. When R is large, you are discounting the future cash flows very heavily. So it goes to 0 and even negative. As you can see, the NPV has this nice monotonic shape. It is negative on the right side and positive on the left side. And you are going to have a unique point in which the line crosses the x-axis. And this is going to be the internal rate of return of around 13%.